Natural disasters, such as flooding, defined by overflowing water onto land that is normally dry, are somewhat unstoppable. Development and occupying floodplains land remains a perpetual risk, even if flooding rarely occurs. Hence, focus on planning is essential in managing sustainable water flow and land development to reduce the adverse impact of flooding. Development of building, design, and its materials used provide opportunities to limit the vulnerability to flooding. This allows better awareness, understanding, and management of flood risks, and, as such, minimizes potential losses and damages. Under FEMA, Federal Emergency Management Agency, flood damage-resistant material are identified and set as a platform for new construction and significant remodels. FDR material, defined in the context as any material capable of withstanding direct and prolonged contact, at least 72 hours, with floodwaters without sustaining significant damage, i.e. requires more than cosmetic repair. By using the flood-resistant wall and partition materials, high rectification cost and savings for restorations are reduced significantly. Fiber cement is categorized as Class 5 of the flood-resistant materials under FEMA in the United States of America. Class 5 is the highest category in the flood-resistant materials list. In reference, PRIMA's RNPD monthly bulletin titled PRIMA Board and Flooding Restoration highlights PRIMA Board's restorations after flooding, deeming PRIMA Board's recyclable properties. PRIMA Board's flood-resistant test is a test to examine and evaluate the material's behavior after immersed in water for 72 hours to simulate flooding conditions. Observations after 72 hours of water immersion. The wet area plasterboard shows symptoms of a broken edge, board cracking, and warping. In comparison, PRIMA Board did not show any negative sign of warping, cracking, and none of the broken edge recorded, concluding PRIMA Board's sustainability when subjected to flood. Recent survey amongst house owners states that housing loans take up the biggest chunk of total household expenditure. With such an investment for a home, then maintenance and rectifying cost considerations become relevant to homeowners. Choosing the right materials for wet area applications would then assist with reducing or even eliminating these potentially high costs. One of the most common defects of building is the failing bathroom or wet areas applications. The wet area test merely gives an illustration of impact in a simulated environment of continuous water showering for 30 days, providing guidance and serving as better practice on selected building materials for internal constructions. 2 bathroom units erected using different wall materials, one of which PRIMA Board fiber cement and the other wet area plasterboard, but with similar construction specifications as lining boards prior to laying tiles. Notice that after 30 days of the showering test, the plasterboard's lining wash basin already sinks down, obviously due to losing integrity when contacted with water for a long period. The plasterboard's specimen area, the basin, starts sinking down, and mold is found growing on the back of the board surface. Additionally, water seepage through the fastener point or supporting bolt gradually occurs. PRIMA Board's proven durability and water resistance compared against defects found using plasterboard when subjected to the showering test. There is no movement of the basin, no water seepage, and no mold detected. Choice concluded. PRIMA Board. We're always building brilliantly.